Hello, everyone. I'm Ryan Hild. I am a DevSecOps engineer. I work at Starbucks.
I've got with me. My name is Aaron Jahoda. I'm a principal solutions architect with Signal Sciences.
Yeah. Yeah. So our meme game isn't quite as strong. We thought we were going to be pretty good, and then we saw all those memes just kept coming and coming.
We may compete for oldest meme, though, so we'll see.
We'll see. All right, so today we're going to be talking a little bit about Ingress controllers and how you can increase your application security by auto-scaling these. Once again, my name is Ryan Hild, and Aaron. Yep. So what we're going to be talking about today is a little bit about why Kubernetes makes sense at Starbucks. Some of the reasons that we chose it as a platform. Then we're going to talk a little bit about Ingress, what it means to secure your Ingress, and especially to do that at scale. Then we're going to talk a little bit about our implementation and some of the different pieces that went into one of the projects that we worked on. And then we're going to bring it all back together and talk about what we just went over. All right, so first off, we have a vision for a platform. And this comes from a series of business requirements set out by the organization. So, we want to have global parity of services. When we deploy an application to our North America users, that means both the United States, Canada, Mexico. We also want to see that same application eventually going out to Japan, Europe, China, all these different markets, right? We also have the need that we want our developers to be able to build these applications and iterate on them quickly. So we can get these things out to market and then react to how our customers like that application or different needs that we have. We also want to make sure that these processes are scalable. So, if we have an update that works for 10% of our users, we want to be able to quickly roll that out to all of our users. And then, of course, this is a KubeSec talk, so we want to talk a little bit about how security is part of that background that we build this platform with. We have a responsibility to build, maintain, and audit that trust throughout our system. So Kubernetes naturally fit into this as the platform that we chose to deploy upon. And we built what our internal platform is called is the CFS platform, the Cloud Foundation Services. And this is our repeatable, automated, secure environment. And the idea is that you're able to, if you're a developer working on one of our internal projects, you're able to make a request and stamp out Kubernetes namespace for yourself within a matter of minutes. So some of the projects that we have out there running right now are the Japan Loyalty Rewards Program and the Airport Mobile Order and Pay. So if you go to Japan and you earn stars, they'll be going through our platform. If you go to any of the airports that currently offer mobile order and pay, it'll also be running through our platform. So we've got a little bit of experience running these things in production. And kind of one of the key parts of how we work is we are a DevSecOps team. And what that means to us is that security is part of how we work. We expect all of our engineers on the team to be able to wear the development hat, the operations hat, and the security hat. They need to be thinking about security so we can bake it into our designs. We need to be thinking about security when we go out to deploy these things. And it just really is an all-around concern that we have. Our team is responsible for overseeing the entire platform. And this is really what enables us to be that DevSecOps team, is the idea that our team owns the services, the infrastructure, and we're ultimately responsible for all of those different pieces all throughout our stack. Now, this differs from our tenants in that our tenants are the ones that are actually running the business-facing applications. We just provide that compute and services platform for them. All right, so to get a little specific, we're going to be talking about Ingress. And some of you may be familiar with what Ingress is. Some of you might be asking yourselves what that means. Well, for us, that means the idea of you have a publicly exposed endpoint, and it needs to get into your microservice, right? There's a lot of different pieces that go through to get down to there. We typically have an API gateway somewhere. We have an edge load balancer out there. We have an Ingress controller running on Kubernetes, and then we have our application services. Each different platform is going to have these organized in a different way, but all these things form the pieces that we have into our architecture. So every request that comes into our system is going to need to hit all these different pieces to get all the way through. So when we think about securing that, what are some of the security controls we can put in place to kind of help manage our ingress paths? Well, we want to make sure we got our API keys and we've got that configured and available to our developers. We would like to go ahead and use MTLS to secure our connections because we have a known API gateway that's going to be reaching through our load balancer. We also want to make sure that we are using, just only opening the proper ports on our edge. And the reason for this is there's a lot of attacks out there. We've seen a couple statistics right before lunch going over how we've got these layer 2, layer 3 attacks. We got to be watching for those. We also got needs like SQL injection, cross-site scripting, were a couple of big ones out there. So we need to put in controls such as like a WAF to help respond to these. So as we developed our application, we started stamping out these namespaces. We started out by provisioning these manually. That's the best way to learn something is to try and do it by hand once or twice and see how that goes. However, what we found is that it was taking us quite a long time to spin up each new namespace as we got the requests coming in for them. If you had a developer or one of our engineers who wasn't familiar with the process, it could take 2 weeks to spin up a new namespace and have it ready for use by that developer. So our solution is to automate all the things. We decided to take this and we said we can build an application that controls this entire ingress path. And because we're a DevSecOps team, we'll own the development, delivery, and maintenance of that application that manages this path. So yeah, some of those concerns that we had were just making sure that we have our DevSecOps team is going to be managing this application's entire lifecycle. So the pattern that we developed is what we call an ingress orchestrator. And this is a Kubernetes native application that we deploy out to our clusters. And what it'll do is when we create a namespace, we create a custom Kubernetes object within this namespace. And then our ingress controller picks up on that. And it's going to go out there, it's going to configure an ingress controller for that namespace. It's going to create some TLS certificates. It's going to provision a DNS name so we can uniquely identify that set of endpoints. And it's going to configure our API gateway to be able to talk to it. As I said, we had MTLS configured. We got to make sure we got certificates in both places. So I'd like to talk a little bit about the implementation. I'm going to go over a little bit of the external objects that we configured, and then Aaron's going to take over and talk about some of the stuff that we did inside the cluster. So the way we started that was with that custom Kubernetes object that I was talking about. And this is just an example, but the basic idea is you set up this object, and Kubernetes manages the lifecycle of it. You create this using your standard kubectl commands. You can apply, patch, update, and delete. And you also have, assuming you've got RBAC on, you also have access controls around this. So we can say there's certain cluster operators that are allowed to create namespaces and create and manage these objects, but they're the only ones who are allowed to do so. So one of the first things that we do is we configured, HTTPS. And there's a couple different ways to set this up. So if you've got, let's say, one-way TLS coming into your cluster, you can go ahead and have your ingress orchestrator spin up a publicly signed certificate, like using the Let's Encrypt, the ACME protocol, to go ahead and provision yourself a certificate. And you can install it and have it ready for your ingress controller to consume. In our case, we had everything set up with MTLS through to our API gateway. And so what we did is we had to provision 2 separate CAs, 2 certificates from that, and then we had to make sure that those were all installed in the correct places. If you've never done this before, this is probably going to take you a couple of tries just because you have to learn about the entire concepts of creating that PKI hierarchy and then making sure that you have all your trust in the right places. So what we did is by putting this inside the ingress orchestrator, we can codify that so that our infrastructure is provisioned through code. And one of the interesting ones that we encountered was DNS. When we provisioned our DNS entries, the way that this started was, we'd spin up a Kubernetes service using the load balancer type, and it would go out there and provision a load balancer from our cloud provider. Now we would take that and then we would create another DNS record, and so this is like a manual two-step process. Well, we found this project called external DNS, and we had to do was run their controller in our clusters, add an annotation to each of our services, and we automatically get our DNS names configured. So now I'm going to pass it off to Aaron.
Awesome. Thanks, Ryan. So in my quick section here, I'm going to talk about web application security and how we implemented a next-gen web app firewall into the environment that Ryan's been discussing. So first off, Kubernetes obviously gives us an amazing amount of flexibility and scalability with how we can choose to deploy our applications. And I think it kind of goes without saying, considering where we are in the talks we've been listening to, there arise some interesting challenges then around securing those applications as we deploy them. So number two, when we focus on application security, one of the big considerations is the balance between how our application architecture scales, especially with regards to the number of applications that we can end up with in a common environment. The balance between that and the potential management overhead of the security tools that we put into place. So pertinent to the implementation that I'm going to talk about here, an example of this is the web application firewall and web application firewall policies. The trick here is that the kind of traditional WAF model is one based around managing policies or rule sets on a per application basis. So as you add more and more applications to the environment, as Ryan's discussing, you'd ideally not like to add correspondingly more and more web app firewall policies to keep that overhead low.
Yeah, as you think about it, if you have each individual developer is spinning up a namespace, not every one of those developers is going to be familiar even with the concept of having this WAF that they need to configure. So our biggest win was the idea of having this abstracted so they didn't have to deal with that, but still giving them the controls to be able to use it when they needed to.
Precisely. So to that point, number three here, Starbucks requirements for this project was a kind of next generation web app firewall approach, one that could automatically scale and cover any of the applications that were brought online, and one that did so in a way that didn't require that rules tuning overhead. So to that, I'm going to talk about how we implemented the Signal Sciences next-gen WAF at Starbucks, and I'm going to just start with a super high-level architecture of kind of the tail end of the diagram that Ryan was showing earlier, where you have your ingress controller object over on the left, and the ingress controller is routing requests to your application deployments and pods. So because Signal Sciences is deployed as a software binary, there's a number of different ways we could think about how to deploy into this path. So I'm going to talk about a couple of the different ways you might think about where to put a web app firewall, and then the ultimate option that Starbucks chose to fit their deployment patterns. So first, if we zoom into the application pod itself, look at the existing application container, one option would be to drop Signal Sciences in as a little sidecar to the application container. So as requests flow down to the application itself, the WAF's present there, and requests can be inspected at that layer. Another option might be to move it a layer up, so to think about putting the WAF in as kind of a mid-tier service where you have your ingress controller passing requests down, and you have an intermediate service there with a little reverse proxy that inspects the requests before reaching down to the application. But then thirdly, since we're talking about the ingress controller specifically, another way to think about it would be to actually drop the security layer right into the ingress controller itself. So Ryan mentioned using Nginx in this case. There's obviously a number of different ingress controllers you might be able to use. But in either case, kind of similar to the application deployment, you could drop the WAF right in as a little sidecar to the ingress controller itself. Now, the benefits of this kind of installation option, because really all three of those that I just mentioned are completely viable in different circumstances, but what made a lot of sense for Starbucks in this case, and why they chose to go with the ingress controller deployment pattern, is because installing at this level gives you a centrally owned and managed location, and one that then gives any deployments that come online automatic protection. So no matter what we spin up in this multi-tenant environment, you have automatic then web application protection from the get-go. So awesome. Turn it back over to you, Ryan.
All right. So I know that was a lot of different material to cover, but let's bring it all back. Like, what do we get? Well, first off, because we've got these automatically being spun up, like whenever we spin up a new namespace, we create one of these objects. That means that every single object behind every new namespace, if it's externally accessible, it's already using a path that's been vetted by our security process. It allows us to spend more time developing our features rather than focusing on configuring new namespaces. Like I said, we brought that time down from about 2 weeks to now it spins up in 5-10 minutes, most of that time being the time it takes for the DNS name to propagate fully. We also, because we own this process, we own the visibility. So we are able to monitor it. We are able to run metrics on it and be able to adjust our deployments as we see fit. And finally, like the big key win here was this improved our security and our operations posture. I know we talked a little bit about rotating keys. We went from rotating keys we install these TLS certificates with a year expiration. We've now brought that down to weeks, days. And it's all automated, so we can trust that those certificates are going to be renewed. And because we own the monitoring on it, we're alerted when they're not able to be renewed. So just a couple things if you're thinking about doing something like this for yourself. Be prepared to evolve your architecture to support your needs. As an example, we had our Ingress controller initially deployed once per namespace, and we've been able to use this kind of automation to test, well, what if we had one Ingress controller per cluster? What are the trade-offs that we get there? Is there a benefit that we can get out of that? We've talked a little bit about network policy objects. Ours are, quite frankly, pretty boring because we have a single API gateway that's allowed to talk to our ingress paths. But if you have dynamic needs around this, like you have dynamic clients that you're going to need to talk to your different clusters, you may be able to add some automation around this and make it so it's a much more automated process. And then the last point that I'd like to really hit on is don't build it yourself if you don't have to. When we designed and we built this process or this whole architecture out, it was because we had all these custom tools and we wanted to bring it together, and we were tired of doing this by hand. As time goes on, there's going to be more and more tools that people build up like this that they are able to bring into maturity, share with the community, and do those sorts of things. An example of that being the external DNS project that we used. That would have been very easy for us to have written, just a couple of API calls out to, our DNS provider to say, hey, go ahead and update this CNAME. But if it's already built and maintained by somebody else, that's a win, so we don't have to build and maintain and own that piece of software. And that's all we have. So thank you, everybody, for your time. And we've got...
Yeah, let's take a couple of questions before we go to break. I'm sure a lot of people have questions. I'm sure a lot of people have questions, but nobody's raising their hand. Okay.
Since nobody else has any questions, I'll ask two. First one probably on everybody's mind. Have you put this on GitHub?
No, we have not. It's not quite at the maturity level it needs to be an open source project.
Sure thing. Can you give any examples of how you've done any automated testing or behavioral testing to demonstrate the behavior of the controls you've tried to implement are actually functioning?
Certainly. So one of the big ways that we've been testing this is we have a test namespace that we spin up every once in a while, well, on demand at this point. So we deploy a test namespace, and then this ingress controller, this ingress path object will be created for that namespace, and then we have a test infrastructure that will reach out through our API gateway and communicate with services behind it to test that we have that connection, and then it will do also the reverse of making sure that we don't have access to services we're not supposed to.
All right, great. One more question here. Oh, sorry.
So, as to existing open source projects, did you look at some of the Istio and Envoy projects that cover some of these components?
That's kind of to my last point is since we've developed this, there's been a lot of active development in this space. It really depends on the needs of your project. We found that at the time that we were implementing this, there was no project out there that we could find that did everything that we needed it to.